Alright, so the notes that we're covering today are the notes for section 9.3 on histograms and box plots. Go on ahead and copy down the objectives. So there's two things that you want to be able to do by the end of the notes today. The first thing is to construct histogram and box plots, and then the second thing you want to be able to do is to use histogram and box plots to analyze data. So we'll be doing both of these things today. When you're copying down the definitions for histogram and box plots, don't forget to draw in the picture. Your picture doesn't have to look exactly like mine. This is just an example of what a histogram looks like. A histogram, sometimes in other classes that you've taken, is called a bar graph. And another word for a box plot is sometimes you'll see these called box and whisker plots, and so in case you see them referred to by these other names, it's good to know that those things mean the same thing. So a bar graph or a histogram is a bar graph used to display the frequency of data in equal intervals. And so this is just a picture of what a bar graph might look like. A box plot is a different type of data representation, and so the definition here shows that it can be used to show how a data set is distributed, and it has a box and then these two whiskers. So it's actually two boxes. The end of the box here is Q1, the end of the box here is Q3. This point's the minimum, this point is the maximum, and then this point right here, it's not in the middle, but this point right here that's sort of in the interior of the box, that's Q2. So to make a box plot, there's 5 things that you need to find. You need to find the minimum, Q1, the median, which remember that's also the same thing as Q2, Q3, and the maximum. So for question number 1, we're going to use this histogram over here. It's talking about the weights of dogs that are in a shelter, and we're going to answer the following questions based off of that histogram. So the first one says, which weight range has the most amount of dogs? That's going to be the highest interval, the highest bar on this histogram. Sometimes it's helpful to go through. We're going to be answering a lot of questions about this graph, so all I'm doing right now is above each bar, I'm writing down the amount of dogs that are indicated with each of these weights. That might help us later on answer questions. We don't necessarily need to do it for this first problem, but it'll help us out for the rest of them. So which weight range has the most amount of dogs? You're just looking for the highest bar, and so dogs that are between the weight of 30 to 39 pounds, there's the most of those. Question B says which weight range has the least amount of dogs, and so that would be right here, 60 to 69 pounds. Because that bar on the histogram is the lowest. What is the total number of dogs in the shelter? So to answer this question, we would add up 15, 10, 20, 40, 35, 25, and 5. And so by adding up these values, we would arrive at the answer that there's 150 dogs in the shelter. It's helpful for me to note that you're not adding up the numbers that go along the bottom. You're adding up the numbers for the heights of each bar, because that represents how many dogs are in each of the weight classifications. Question D says, how many dogs weigh, or I should say dogs, how many dogs weigh between 40 to 49 pounds? And so to answer that question, you'll simply go to that interval along the bottom, and you'll go up to the top, and so there's 35 dogs that weigh that amount. To answer question E, we're going to need to go onto a separate piece of paper, and so here I'm going to write a note to see attached work. And so to answer this question, we'll switch over to a separate piece of paper. So again, to do the work out for question part E of question 1 on the notes today, we're going to do the work for this out on lined paper. Just make a note that you're going to use this tonight in your homework when you do questions 6, 7, and 8. Alright, this has a lot of work. You're trying to use a histogram to estimate a mean. And so the tricky thing is when you have a histogram like this one about the dog's weights, there's 15 dogs that weigh between 0 to 9 pounds, but they don't tell you what their exact weights are. So it's not like when you find a mean where you can just take the numbers, add them all up, and divide by the total. You have to use the amount that's in each of the intervals. So we're going to be using these numbers along the top to find sort of like a weighted average for each of the intervals. So the first thing I did on my paper was I labeled it first interval, second interval, third interval, and then I went all the way down to 7th, because on the graph when you count it, there are 7 bars. 1, 2, 3, 4, 5, 6, 7. So the number of times that you have to do this will be determined by the number of bars that there are in your graph. So we label which interval we're doing. 0 plus 9, I take the low end of the interval and the upper end of the interval and I average them together. So I divide them by 2, and then I'm going to do that for each of the intervals. So looking at the dog problem, so 10 plus 19 divided by 2, 20 plus 29 divided by 2, etc. The number that's inside the second part of the parentheses is how many values were in that data interval. So there were 15 dogs that weighed between 0 and 9 pounds. And so times 15 times 10 times 20, etc. I'm going to hold the, I'm going to display like the first half of it right here, and then I'll move it down in a second to show you the second half of the work. So what you do on your calculators is you do 0 plus 9 divided by 2, and that gives you 4.5. And then you multiply that number by 15 because that's the number of data intervals or data values that were in that interval. For the second interval, 10 plus 19 divided by 2, that gives me 14.5, and then I'm going to multiply that by 10 because there were 10 values in that interval. And you'll continue that process for each of the intervals that are given to you for that particular data set. These numbers over here on the side, and again I'm showing you the ones for these first 4 so that you can do the work and copy them down. These are the numbers that you get after you multiply the two numbers together. So 4.5 times 15 gives you 67.5, 14.5 times 10 gives you 145, and then so on. So again, I'm doing this for each of the 7 sets of data. Let me just adjust the camera here so you can see the rest of it. And then here's the work. You may have already copied down the one for the 4th interval, but so here's the work for the 5th, 6th, and 7th interval. So again, these numbers on the top, this is the low number in the interval, this is the high number in the interval. I'm dividing it by 2, and then I'm timesing it by the number of values that's in that stack. So just to show you another example, for this 6th one, I did 50 plus 59 divided by 2. That's where I got the 54.5 from. And then the reason why I'm timesing this one by 25 is because when you look on the stack, there's 25 dogs that are in, or values that are in that data interval. And so again, these numbers on the end come from multiplying this number times this number. Once you have the list of all 7 numbers that are over here on the side, the next part that you're going to write down on your notes, let me just adjust the camera again. It says you're going to add the results and divide by the total number of values in the data set. So what I'm doing here is, since I can't add up all 150 weights of the 150 dogs and find the actual mean, I'm trying to find an estimate for the mean. And so to do that, I'm going to add up the 1, 2, 3, 4, 5, 6, 7, these 7 numbers that I got here down the side. I'm going to add those 7 numbers up. When I do that, I'm going to get a big old number on the top of that fraction. And then I'm going to divide it by, in this problem, 150. Remember, we already answered that question on the page in our notes. Question C asked what was the total number of dogs in the shelter. So this isn't getting divided by the number 7, it's getting divided by the number 150 because that's the number of total values that there are in this entire data set. And so when I type that into my calculator and I do the division, I get 35.5. Remember, 35.5 means 35.5 pounds. That we were trying to figure out what a good estimate was for the mean of a dog in the for the weight for a dog in the shelter. So 35.5 is the number of pounds, and again, it's a good estimate for the mean of this data set. It's not the actual mean because with a histogram there is no way to find the actual mean since the data numbers, the data values aren't actually listed out for us like they are in different kinds of graphical representations. So again, the work that you did on this problem is going to be helpful tonight when you do questions 6, 7, and 8 on the homework for 9.3. And for the final question on the first page of the notes for today, it says a student claims the data has a symmetric distribution. Do you agree or disagree, and explain your reasoning? So remember, to answer this question, you need to look at the shape of the graph. Remember from the notes from yesterday, symmetric means that it's the same on the left as it is on the right. And so looking at this graph, you see that it's much more piled up over here on the right-hand side. And so we would disagree with this question. It says to explain our reasoning. Part of the reason that you could offer as a disagreement for this question is you could describe that the data is skewed to the left. and so the data isn't equally distributed on both sides. It's definitely more piled up over here on the right, and which means, as we covered yesterday in the notes, that the data is skewed to the left. Question number 2 in the notes gives us 2 different sets of data, and it wants us to develop 2 different box and whisker plots. So it says to make a box and whisker plot for each category on the same number line. So let me talk through the beginning part. Label the first set of data, number 1, and label the second set of data, number 2, and then that's how we can refer to the 2 data sets throughout this example. Alright, so for the first data set, remember that to make a box and whisker plot, or a box plot as they're often called, you need to know 5 numbers. You need to know the minimum, you need to know the maximum, and I'm pointing here and here because for these 2 sets of data, they're already given to you in numerical order, which is really nice because you don't have to rewrite them and put the numbers in order. If the numbers were not given to you in order, you would need to do that. So, okay, you need to know the minimum and the maximum. And then to make a box and whisker plot, remember you're going to need to have 5 different numbers. So that's my minimum, that's my maximum. I also need to figure out my median, or my Q2. And so my median, let's see, there's 8. 1, 2, 3, 4, 5, 6, 7. There's 8 numbers. So to find my median right here, I add up these 2 numbers and divide by 2. So that would give me 99. That's my Q2, or my median, for the first set of data. To find Q1, I cover up the top half of the data, and I'm just looking at these 4 numbers right here. So my Q1 right here, I would add up 92 and 93 and divide by 2, and that would give me 92.5. And then over here to find my Q3, I would cover up the lower half of the data, and again I'm just looking at these 4 numbers here. So my Q3 for the first set of data for number 1, I would add up 102 and 105 and divide by 2 until I get 103.5. I would then repeat that process for the second set of data. So minimum Q1, Q2 maximum, Q3 and maximum. Once I have those 5 numbers, and I've written them down here in a list format, which sometimes students think is really helpful, you don't start by drawing the boxes. The first thing you do with a box and whisker plot is you put the 5 points in the 5 places. So for the first data set, which I drew on the bottom, I put dots or points at my 5 values. So 90, 92.5, 99, 103.5, and then 108. And then I repeated the same process for the second set of data. So my 5 important numbers for that one were 85, 88, 93, 100.5, and 104. Once I have the 5 points on the graph, the first and second points are always connected with a line. And then the second, third, and fourth points on both of them become the boxes. And so that creates the distribution for the box and whisker plot. When you draw the box, this line for the whisker doesn't go all the way through. It's more customary that it stops here and then the box is drawn. There is usually a vertical line drawn through Q2. So again, from your box and whisker plot, you can answer questions about the graph. This problem asked us to write a couple of sentences about what the box and whisker plot shows us. And so for this one, I went ahead and analyzed the question, and I said the first situation has a higher maximum, and then the second situation has a lower minimum. And so to analyze that, I said that means that the longer that the infant was exposed, the lower the infant scored on the test. So you can use a box and whisker plot to help you see and understand the distribution for how a set of data is constructed. Alright, and so the last example on the notes for today, the box and whisker plots for both of these 2 situations have already been created for us. And so on this one, we're kind of doing the opposite of what we did up above. We're going to pull the numbers off the graph. So remember, when you create a box and whisker plot, there's 1, 2, 3, 4, 5 important points. So we're going to pull that data off of the graph. For Miami, Florida, it looks like the minimum, we're just estimating, so it looks like it's maybe about 1.8. Q1 is the point that starts the box. And so, I don't know, maybe 2.4. Again, these are just estimates. The median looks like it's right around 4.5. Again, we're rounding to the nearest tenth, it's fine. The median's the line that goes through the interior of the box. This one's maybe 7.2 for Q3. Again, these are just rough estimates. And then for the maximum, it looks like it's at about 8.6 or maybe 8.7. For New Orleans, that's this box and whisker plot down here. The minimum point looks like it's at about 3. Q1 is maybe around 4.9, again as an estimate. The median looks like maybe it's around 5.4. Q3 looks like it's right around 6. And then the maximum for this one is at maybe at like 6.9. And again, that's just as an approximation. The final questions on the notes for today ask us to examine these two box plots that we were just offered. Question C says, which group has a larger average monthly rainfall? And so, understanding that there's different ways to interpret this question, Miami has the higher maximum average monthly rainfall. New Orleans has a lot more data points that are concentrated in this sort of 5 to 6 inch area. But considering the data that's presented to you, we would conclude that Miami would have the higher average monthly rainfall because the maximum and third quartile are higher than all of the rainfall in New Orleans. To answer question D, you want to make sure that you show out enough work. So D asks us which group has a larger range and which group has the larger interquartile range. And so to do the work for this question out, remember that to find the range, you're just doing your maximum value minus your minimum value. So for Miami, 8.6 minus 1.8, the range for Miami is 6.8 inches, and the range for New Orleans, when I do maximum minus minimum, gives me 3.9. So comparing the range of these, Miami's range is more. And that makes sense when you look at the box plots. See how far apart the minimum and maximum values are for Miami, and then see on New Orleans how the minimum and maximum values aren't as spread out. So Miami's range is more. And then for the IQR, a reminder of the notes that we did previously, interquartile range is Q3 minus Q1. And so I do the work for that for Miami. Q3 minus Q1 gives me 4.8. And for New Orleans, Q3 minus Q1 gives me 1.1. And so the IQR for Miami is also larger. That doesn't mean Miami's better. It actually just means that the data values, when a range or an IQR is larger, it means that for both of these, the data is more spread out. So it means that the numbers are actually further apart from each other. It's not necessarily like a better or a worse thing. If you look up here at the graph, one thing that I want to make sure that I reinforce to you is that the range is the minimum and the maximum subtracted from each other. So it's these 2 points that you're looking at. But when you're finding the IQR from a box plot, you're actually just figuring out the length of the box, because this is Q1 and this is Q3, and then for New Orleans this was Q1 and this was Q3. So to figure out the answers to the questions for that, you're just finding out sort of like the size or the length of the box that's in the box plot.